are dispatched to service a residential split system air conditioner. Your dispatcher says the compressor runs, but the system is not cooling adequately. When you arrive at the job site, the homeowner tells you the space temperature is 85 degrees and the thermostat is set at 75 degrees. You proceed to conduct a power-off system inspection. You look at the air filter, check fans and blowers that they are clean. You check for dirty or corroded coils. Check to see if the TXV bulb is properly located and properly insulated. Visually inspect the outdoor unit for any problems and check the coils and refrigerant piping for any oil stains which could indicate a leak. So you do a power-on inspection of the system. You observe the sound of the compressor as it starts up and as it's running. Is the outdoor fan turning in the correct direction? Is there proper airflow over both the outdoor coil and the indoor coil? If nothing out of the ordinary has been found up to this point, then we must take some readings using our service tools. Just like a doctor will take your vital readings to determine what is wrong with you, the service technician takes vital readings to determine what is wrong with the system. We are going to read the vital signs of the system. So with a thermometer that can read dry bulb and wet bulb temperature, we read our outdoor dry bulb temperature at 90 degrees, our indoor dry bulb at 85 degrees, our indoor wet bulb at 72 degrees, and our evap coil leaving air dry bulb is 65 degrees. With a temperature probe, we read our actual suction temperature at 61 degrees, and our liquid line temperature at the condenser outlet as 112 degrees. With our manifold gauge, we read suction pressure at 102 pounds, saturated suction temperature at 60 degrees, discharge pressure at 297 pounds, and our saturated discharge temperature at 130 degrees. Now we'll need to calculate the subcooling temperature using the values we just measured. Our liquid subcooling is calculated by subtracting our liquid line temperature of 112 degrees from the saturated discharge temperature of 130 degrees. So our actual subcooling is 18 degrees. Our superheat is calculated by subtracting the saturated suction temperature of 60 degrees from the actual suction gas temperature at the compressor of 61 degrees. So our actual superheat is 1 degree. We then record all our readings on our refrigerant side troubleshooting form. Also note that we record the type of refrigerant we are working with, which in this example is R22. We have recorded the actual readings. Note that on this worksheet there is a place to record typical readings. Typical readings, or ballpark readings, can be gotten from manufacturers' data sheets for specific units, or you can develop your own typical readings. When you are doing maintenance on a system that is working properly, take down and record those vital signs so that when you are working on a system that is not working correctly, you can compare the vital signs to determine what your problem is. Build your own troubleshooting library. We now have our completed troubleshooting form. We have our actual readings and our typical readings so we can compare and determine what the problem is with this system. By comparing our vital signs, we find that our discharge pressure is higher than normal, our suction pressure is higher than normal, our superheat is very low, our subcooling is higher than normal, and our compressor running amps are high. The next step in our troubleshooting process is to compare our findings to the basic system analyst chart. The only condition that fits the combination of symptoms we have is a system overcharge. So the next step for this tech would be to recover the entire charge of this unit and pull a good vacuum on the system and then weigh in the correct factory charge for this unit.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.